Hello and welcome to this video. In this video, we will solve next 10 problems, that is problem number 21 to 30. So without further ado, let's get started. As always, I'll say the same thing, that when I'm stating the problem, you should pause the video and try to solve the problem yourself. When you cannot solve the problem yourself, only then look at the solution. So with that out of the door, let's solve problem number 21. Problem number 21 says that find the number of complex numbers, that is find z cube plus z bar is equal to 0. So we can write that z cube is equal to minus z bar because we take it to right hand side. So we can write that mod of z cube is equal to mod of z. Now we bring mod z to left hand side, so it becomes mod z into mod z minus 1 into mod z plus 1 is equal to 0. Now one of the solutions would be mod z is equal to 0. So that gives us mod z is equal to 1 because mod z plus 1 is greater than 0. So this is the other solution. So mod z cannot be minus 1, alright, because mod z is positive. So this will give us no solution. So there are two solutions, mod z is equal to 0 and mod z is equal to 1. Now if mod z is equal to 0, then z is equal to 0. Second solution, we take into consideration mod of z is equal to 1. We square both sides, we get mod z square is equal to 1. Mod z square is z bar is equal to 1. That means z bar is equal to 1 by z. So we substitute the value of z bar in the original equation. We get z cube plus 1 by z is equal to 0. That gives us upon LCM, it will become z to the power 4 plus 1 is equal to 0, which will have 4 distinct roots. So 4 roots from here and 1 from here. So that means it will have total 5 roots. Problem 22 says that find the number of real roots of the equation z cube plus iz minus 1 is equal to 0. So here we have to find real roots. That means imaginary part will be 0. So we let z is equal to x, which is a real value. So given equation is x cube plus ix minus 1 is equal to 0. Now x cube is equal to 1 and x is equal to 0 because we compare real and imaginary parts. So if x is equal to 0, then 0 cannot be equal to 1, and x cube is equal to 1 means x will have the cube root of 1. Okay. So you see that there are no possible solutions. That means it has no real solution. Problem number 23 says that in the following diagram, if given circle is unit circle, that is this circle is unit circle, then find the reciprocal of point A, that is this point. So we let z is equal to x plus iy for point A, then square root of x square plus y square is greater than 1 because point A is outside circle and circle is unit circle, that is radius will be 1. So once we have this, 1 by z is equal to x 1 by x plus iy. So we multiply and divide with x minus iy, which gives us 1 by z is equal to x minus iy by square root of x square plus y square. So clearly x by square root of x square plus y square and y by x square root will be the square root of x square plus y square, both will be less than 1 because our point lies outside the circle. So this is greater than 1. Now this means the yh component is negative, that is, and a real component is positive. That means it will lie in the fourth quadrant. So if you look at the points in the fourth quadrant, there is E and there is P. But since the modulus of this will be greater than 1, the modulus of reciprocal will be less than 1. So point E is the only point which can satisfy the required condition. Problem 24 says that if z is equal to 3 plus 7i into p plus iq, where p and q are in a set of integers, is purely imaginary, then find the minimum value of mod z square. So we are given that z is equal to 3p minus 7q plus I into 3q plus 7p. So if you multiply both the given terms, you arrive at this value. Now this is purely imaginary. That means the real part will be 0. That is 3p minus 7q is equal to 0, which implies p by q is equal to 7 by 3. We add I to both sides, we get p plus iq by q is equal to 7 plus 3i by 3. This implies that p plus iq is equal to 7 plus 3i. Now we substitute this value in the original equation, we get z is equal to 21 plus 9i plus 49i minus 21. So 21 will get cancelled and it will be 58i. So mod z square will be 58 square, which is 3364. Problem 25 says that if alpha is equal to a minus ib by a plus ib whole square plus a plus ib by a minus ib whole square, where a and b are in set of real numbers, then prove that alpha is purely real. So we take LCM, we get a minus ib to the power 4 plus a plus ib to the power 4 by a minus ib whole square, a plus ib whole square. We see that this a minus ib whole square will get multiplied with this, and a plus ib will get multiplied with a plus ib whole square, so powers will be 4. Now you expand this, you get this much, and you expand the second one, you get from here to here. You see the terms containing I, that is 4a cube ib and 4a cube I will get cancelled. 4a I cube b cube and 4a I cube b cube will get cancelled. So what will remain is terms without I, that is 2a to the power 4 minus 12a square b square plus 2b to the power 4 divided by a square plus b square whole square, which is purely real. Problem 26 says that if beta is equal to z minus 1 by z plus 1 such that mod z is equal to 1, then prove that beta is purely imaginary. Now we let z is equal to x plus iy, so mod z is 1, that is x square plus y square is equal to 1. Now z minus 1 by z plus 1 is equal to x minus 1 in plus xy divided by x plus 1 in plus iy. Now we multiply and divide this with x plus 1 minus iy and x plus 1 minus iy in denominator here as well. So upon multiplication and simplification, we get this as 2iy by x plus 1 whole square plus y square. Here x plus y square is 1, so that 1 will get cancelled with 1. That means we will be left only with this term. So you can see that this is purely imaginary. Problem 27 says that if mod of z minus 3i is equal to 3 such that its argument arg of z in 0 to pi by 2, that is its value lies between 0 and pi by 2, then find the value of cot of arg of z minus 6 of z. So this will require some knowledge of trigonometry. If you have not studied trigonometry, you can skip this problem and come back later when you have studied trigonometry. So our given z is x plus iy. So you can see that this is equal to 3. So that implies that z minus 3i, that is it will become y minus 3i into y minus 3. We take the modulus square, that is x square plus y minus 3 whole square is equal to 9. Now if you observe this, then x will be equal to 3 cos theta and y will be 3 sin theta plus 3. So if you put these values, you will get 3 cos square theta plus 3 sin square theta, which will be equal to 9. Sorry, 3 square cos square theta and 3 square sin square theta. So that will be equal to 9. Now once we have x and y, we can write z is equal to 3 into cos theta plus I sin theta plus 1. Now cos theta can be written as sin pi by 2 minus theta, and sin theta can be written as cos pi by 2 minus theta. Now we know that sin 2 theta is equal to 2 sin theta cos theta. That means it will become 2 sin pi by 4 minus theta by 2 and cos pi by 4 minus theta by 2. 1 plus cos 2 theta is equal to 2 cos square theta. So this becomes 2 cos square pi by 4 minus theta by 2. We take out 2 cos pi by 4 minus theta by 2. It becomes 6 cos pi by 4 minus theta by 2. So this will become sin pi by 4 minus theta by 2 plus I cos pi by 4 minus theta by 2. This can be written as cos pi by 2 minus pi by 4 minus and minus theta by 2. which will become cos pi by 4 plus theta by 2. And this will become similarly sine pi by 4 plus theta by 2. So the whole thing becomes 6 cos into pi by 4 minus theta by 2 e to the power I multiplied with pi by 4 plus theta by 2. This is the Euler's form. Once we have this, we can write cot of arc of z is equal to cot of pi by 4 plus theta by 2. Here the argument is pi by 4 plus theta by 2. So this equivalently can be written as tan pi by 4 minus theta by 2. So once we have cot of arc of z, we need to evaluate 6 by z. So when you evaluate 6 by z, this 6 will get cancelled with this 6. And cos will become sec of pi by 4 minus theta by 2. And argument, the power of I will become negative. So this we write as sec pi by 4 minus theta by 2. And this we can write as sine of pi by 4 minus theta by 2. Here parenthesis is missing. It is at wrong place. Minus I cos pi by 4 minus theta by 2. Which is equivalently can be written as, when you multiply this into this, it will become tan pi by 4 minus a by 2, sorry, theta by 2, and this will get cancelled. So that is equal to minus I. So cot of arc of z minus 6 by z is equal to I, because tan will get cancelled with this tan. So what you will have remaining is I only. Problem 28 says that find the polar form of the complex number minus 16 by 1 plus I square root of 3. So the polar form is given by z is equal to r into cos theta plus I sin theta. We take the value minus 16 by 1 plus square root of 3. We multiply it with 1 minus I square root of 3 and divide by the same value. So this becomes minus 4 plus I 4 square root of 3. So that means r cos theta is 4. This is minus 4. So r cos theta is minus 4 and r sin theta is 4 root 3. That means r square will be 64, because that will be r square cos square theta plus r square sin square theta. This is 48 on squaring and this is 16. 48 plus 16 is 64. That means r will be 4, 8. R will be 8, not 4. Square root of 64 is 8. This is a typo. So cos theta will be here. This is minus 4. So minus 4 by 8 is minus half, and sin theta will be square root of 3 by 2. So if you observe these two, it is clear that it is a value in second quadrant, because sin theta is positive and cos theta is negative. So that means theta is equal to 2 pi by 3, and thus we have the polar form of the given complex number. Problem 29 says that if z and w be two complex numbers such that mod of z is equal to mod of w and arg of z plus arg of w is equal to pi, then prove that z is equal to minus w bar. So we let z is equal to r cos theta plus I sin theta, and we have r z plus r w is equal to pi. That means arg of w is equal to pi minus theta, because the argument of z here is theta. So once we have argument of w, we can write w as r into cos pi minus theta plus I sin pi minus theta. Cos pi minus theta is minus cos theta and sin pi minus theta is sin theta. So we take out the minus outside, we get cos theta minus I sin theta. This is equal to r cos theta minus I sin theta is equal to w bar. So thus we see that z is equal to minus w bar. This should be z, not r. Problem 30 says that if x minus iy is equal to square root of a minus b by c minus id, then prove that x square plus y square is equal to a square plus b square by c square plus d square. So here we square both sides. We get x square minus y square minus 2ixy is equal to a minus ib by c minus id. Now we multiply and divide this with c plus id. We get a minus ib into c plus id by c square plus d square. So we get x square minus y square minus 2ixy is equal to ac plus bd minus I into bc minus ad divided by c square plus d square. So we compare real and imaginary parts. We get x square minus y square is equal to ac plus bd by c square plus d square, and 2xy is equal to bc minus ad by c square plus d square. Now we square this and we square this and we add both of these, then we get x square plus y square whole square. So this will become AC plus BD whole square plus BC minus AD whole square by C square plus D square. Okay. So this will be square also. Here square is missing. So once you square these, the term 2ABCD from this and the term 2ABCD from this will get cancelled because of different signs. So what will be left here is a square C square plus B square D square plus B square C square plus A square D square, which is equal to A square plus B square into C square plus D square. So 1 power of C square plus D square from denominator will be cancelled. So what will be left is A square plus B square by C square plus D square. With this, we come to the end of problem number 21 to 30. And I hope you have found this video useful and informative. And so please subscribe to the channel and like the video so that more students like you can benefit from this video. With that, I'll say goodbye for this video and I'll see you in the next video. Enjoy.